Welcome to qnawire.
So in this problem, we have a block of ice displacing some water, and part A asks us to find the volume that is displaced, and the ice cube is made out of fresh water, and the liquid in which it is being placed on is also fresh water. So here we can define a mass to be equal to the density of water times the change in volume. And the change in volume can then be defined as the mass of this water divided by the density of the water. Here, this mass is going to be 16.4 times 10 to the negative third kilograms. And then we're going to be dividing this by 1,000 kilograms per meter cubed. This is going to give us 16.4 times 10 to the negative 6 meters cubed. So this right here is actually going to be the volume that is displaced by the water by the ice cube on the water. So this is the volume that's displaced. Now, part B asks us, is there going to be any water overflow? And the water overflow, the change in volume would occur as the difference as the mass of the ice divided by the density of the water minus the mass of the water divided by the density of the water too. Now, we have to notice that when ice melts, its mass does not change. It simply, it actually becomes more dense. So if this isn't reason enough that there isn't going to be any volume change, which means that there's not going to be any no overflow. But if the math isn't convincing enough, the density of ice is actually less than the density of water, which means that when ice melts, it actually becomes more dense, and it actually loses a little bit of its volume. And when that happens, of course, the ice has more volume than the water after the ice has melted. And given that fact as well, there will be no overflow at all. So, and part C is asking what's the volume displaced by a 9.7 grams, so 9.7 times 10 to the negative third kilograms. And now this is going to be divided by the density of salt water. So this is going to be divided by the density of salt water because this ice cube, this 9.7 gram ice cube, is now being placed in salt water instead of fresh water. So here, we're going to say that the density of salt water is going to be 1,050. So we can say 9.7 times 10 to the negative third kilograms. And then that density is going to be 1,050 kilograms per meter cubed. And we have that the change in, the volume that is displaced here is going to be 9.24 times 10 to the negative 6 meters cubed. And at this point, we can say, okay, if this ice cube were to melt, what would be the change in volume? And if so, will there be any overflow? So this actually would be the 9.7 times 10 to the negative third kilogram, the mass of the ice block, right? Divided by the density of the ice itself. So this would be the density of water once the ice melts. And then minus 9.7 times 10 to the negative third kilogram. And then this is going to be divided by the density of salt water. And here we can rewrite this as going to be 1,000 kilograms per meter cubed. And salt water is, of course, going to be 1050 kilograms per meter cubed. And we find that the difference in volume is going to be 4.62 times 10 to the negative seventh meters cubed. So this right here is going to be the amount of overflow, and once this ice cube melts, this is how much liquid is going to be displaced, and this is how much liquid is going to be overflowed from the container. And that's the end of the solution. Thank you for watching.